What's your predictions? Do you think people are going to adopt Atlas like at scale? This is going to be a big winner for them?
That's a good question because, I can see the benefit to OpenAI. What's the benefit to us as the user?
All that and more on today's Mixture of Experts. I'm Tim Hwang, and welcome to Mixture of Experts. Each week, MOE brings together a panel of brilliant, funny, thoughtful panelists to debate, discuss, and think through the latest news in artificial intelligence. Joining us today are three incredible panelists, so a very warm welcome to Martin Keene, who is Master Inventor, Aaron Baughman, IBM Fellow and Master Inventor, and Abraham Daniels, who is a Senior Technical Product Manager for Granite. There's lots to talk about today. We're going to talk about ChatGPT Atlas, Andrej Karpathy's projections about the future of agents. We'll talk about an interesting paper out of DeepSeek on DeepSeek-OCR. And then finally, we'll ask the question of whether or not LLMs can get brain rot. But first, here's Eiley with the news.
Hey everyone, I'm Eiley McConnon. I'm a tech news writer with IBM Think. I'm here with a few AI headlines you might have missed this busy week. The AI race is long underway, and now Wall Street wants in. Banking giant Goldman Sachs has created a new team that is focusing on financing deals to build data centers and other AI projects. IBM and Groq have teamed up to combine Groq's high-speed inferencing with IBM's AI agent tools, so enterprises can deploy AI agents more quickly and cost-effectively. It's no longer just companies experimenting with AI. Now the military wants in too. Even top generals look to AI chatbots for answers as they practice making decisions quickly, a critical skill in the battlefield. Uber drivers can now earn a little extra cash between rides by doing small digital tasks that help train Uber's AI models. So it's a side hustle within a side hustle. Want to dive deeper into some of these topics? Subscribe to the Think newsletter, linked in the show notes. And now back to the episode.
First off, I really wanted to talk about the big product announcement of the week, which is ChatGPT Atlas. So if you missed this news, OpenAI is now out with its own browser. We've talked about this in the past, but I guess, Abraham, do you want to give us some intuition for why is OpenAI in the browser game at all? Why are they doing what they're doing?
Couple answers to that. I think there's been kind of breadcrumbs in terms of, ChatGPT or OpenAI kind of entering this space with search functionality, dropping last year, as well as, them really being the entry point to a lot of users in terms of how they navigate the internet. So I think one, it was a natural kind of pivot for them, but two, with a lot of the antitrust with, Chrome, as well as, the idea that you could have your kind of history cached as part of your internet experience so that you have a better kind of navigation experience when using the internet. I think it just makes perfect sense for them. Model development is not necessarily as hot as it used to be. So I think OpenAI has been really diligent in terms of finding new avenues to capitalize on their user base, which is, over 350 million people. So I think it's, personally, I think it's a really smart move. And I think, with LLMs kind of being there already, an entry point for most people in terms of how you use the internet, it just makes sense for them to actually, create a browser.
I think these transitions are really hard. I remember when I moved from basic Chrome to Brave, it was like moving house. I felt like it was took a long time for me. They're both Chromium browsers, and so they're actually share a very similar kind of DNA. But this transition from one browser to another is really feels quite high friction. And I guess, Martin, do you have any thoughts on kind of adoption here, right? Because the other one that we've talked about in the past is Perplexity's Comet browser, which is their bid in the space. And there it almost seems oh, well, if you have a company that sells AI as search, it'd become very obvious for you to do an AI browser, right? Because of the kind of history of Google and Chrome. I guess what's your predictions? Do you think people are going to adopt Atlas at scale? This is going to be a big winner for them?
Yeah, that's a good question because I can see the benefit to OpenAI. What's the benefit to us as the user? I mean,
Yeah, that's
clearly
right.
it's
Good question.
yeah. So
Yeah,
can I share two stories of how I've been using Atlas this week?
for sure.
But
Yeah,
when I've
totally.
tested it
Yeah.
out. So I installed this on my Mac, and then the first thing I wanted to do is I had a scientific article that I just kind of open up in Atlas, and of course now you can bring up the tab along the side, which gives you access to ChatGPT, and you can ask questions, and the questions use the open web page's context. So I could ask questions about, tell me what the method and the purpose and the findings were of this experiment, and it gave me all that information. I mean, that stuff I could have done easily by just going into a regular ChatGPT window, right, and just pasting in the URL. But it was kind of handy that it was there. Um, but also in this scientific article, there were a bunch of pictures. So I wondered, could I start asking questions about the pictures and not reference any particular picture, just see if it could figure out which one was appropriate. So I should say the article was about a scientific study of a beer brewing method. And I wanted to ask, did one of the beers look more oxidized than the other, which you can sort of tell because they get a little bit darker in color. So all I said is, did one look more oxidized than the other? And it found the one image that was actually related to that. And then it analyzed the image and it told me, actually, no, I can't see any difference. So it worked. It worked, right? Now again, I could have done that in the ChatGPT browser, but it was just convenient that it was right there. I didn't have to have two windows open. Now, the second thing that I tried was it has built-in agent mode, where it's supposed to be able to basically control the browser for you, fire up a bunch of tabs, do a load of stuff. So I'm a bit of an amateur book collector, and there's one Michael Connolly book that I don't have yet. So I was like, I wonder if the agent can find me the book. So I asked it, I said, look, I want to find this particular book. It's called Nine Dragons by Michael Connolly. I want it to be in hardcover binding. I want a used copy, and the used condition needs to be very good. So it goes off and it's searching a bunch of websites, and you see it kind of working, and it's got some fun animations in Atlas. And it came back with an answer, and it pops up the window with the one that it thinks is best fit. And it found the right book, but I looked at it, and it had the description of the book, and then it had a little picture of the front cover of the book. And I could see that the front cover of the book didn't look right to me. It didn't look like any of the other Michael Connolly books that I'd collected. So all I said was, this cover doesn't look right. And what it did is it went and fired off a bunch more windows as part of the agent. And this time it looked up the ISBN number, and then it confirmed that that is the correct picture for that ISBN number. But then it pointed out, this is the UK version of the book, not the USA version of the book. And you would actually need to use this other ISBN number if you want me to search for that. So again, this was like a really good example, right? Yeah, but the agent did all of the work for me. And again, I probably could have done that in my Chrome browser using chatgpt.com, but I would have been kind of flipping between multiple tabs to do that. So it was beneficial to me just to kind of have it all there in one place.
Uh-huh. So you're pro. You actually are you like, oh, you feel like a month from now you'll still be using Atlas.
We'll see. I don't know.
We'll see. Okay.
Day one, I liked it.
All right, great. Aaron, I've saved maybe the craziest question for you for last. I'm sort of interested in like whether or not in 5 to 10 years there will even be browsers. Right. Like, I think one way of kind of reading the rise of chatbots is, well, if they get good enough, or these agents get good enough, you'll never need to go directly to a website anymore. Right. All of the information will be curated, assembled, maybe everything will be working on MCP. And so like you really will have an internet that is for agents by agents. And so the notion of like you having to browse the web is maybe like this artifact of the past. And so I guess one question for you is like, over the long run, do browsers even make sense as like a category of product?
Yeah, so taking out the crystal ball, and just thinking about the projection
Just
of
polishing
where
it off a
tech is
little
going.
bit.
Yeah, I mean, it's fascinating, because the paradigm's changing. I think that OpenAI, they're looking at turning our computer, our computing devices into a playground, but it doesn't yet have control over the structure and function of that playground, at least yet, right? So we're trying to preserve some privacy, pieces, and it looks like ChatGPT is trying to become more like an operating system, where you can come and use these different applications. It's like an operating system for AI apps. Where in this case, the OS role here is more about like orchestrating AI tools, workflows, plugins, and such. So it's not going to replace, Mac OS or Windows or Linux or so on. It's not aiming to act like a low-level OS that controls this kind of hardware, but it's abstracted up a level, where it handles apps, SDKs, third-party apps, agents, right? And the line between apps and platform, it's beginning to blur a bit. And we have to think too that our computers really aren't built for AI per se. We have to farm out lots of these models, powerful big models, and even the agent wrappers up into the cloud or these big compute clusters, right? And so we need something new, right? And so this is where I think generative AI and generative computing combined together, will help us achieve sort of the future, of what's going to happen. I think some of the risks that we all just need to be aware of, right, is data and privacy. That just making sure that we still can control and decide, what this new OS, right, is going to do and what it can do, right? There could also be these hidden prompts or what we call comet jacking, where there's a lot of these agent risks, right, that could happen, and it just sort of does it by itself, where it hijacks, Comet or hijacks, Atlas, right? There's also less transparency and control that we have as we go, further into the future. AI can make mistakes, as Martin was mentioning before, or at least it seemed like a cognitive mistake, but it actually went, to the UK, found a book rather than trying to find, a book maybe where we currently live, right? So it's like that information graph that it didn't associate correctly to the user. But in essence, that's where I think it's going, and it's going to be fascinating to watch the field, as it sort of begins to change and turn, and it's going to change very quickly.
I guess, Abraham, any thoughts on ultimately like where OpenAI goes with all this? I mean, Aaron kind of name checked sort of the idea of like, well, ultimately their ambition is world domination, right? Like ultimately the ambition is not just a browser. They want to create a thing that like can use any app on your computer. And it starts to look like something which is maybe more akin to like what we would identify with like a lower level operating system. Is that where they're headed with this ultimately?
They've already added features in which they can start to plug into apps on your desktop, laptop, and as part of just the ChatGPT feature. So in terms of plugging into your apps, like I think they've already gone down that route. When I think about how people use the internet today, when I say people, I don't mean researchers or individuals that maybe are a little bit more acutely aware of generative AI. I'm talking about your everyday user. They see it more as a fix-all tool. So they don't have the same, in my opinion, guardrails or, specific issues with some of the security around using it. They see it as kind of, my generation would have saw Google, where this is a truth search engine. Whatever comes up is typically going to be
right, is real.
accurate. Yeah, exactly. So for the average user, I think having something like Atlas, one, simplifies their internet experience. So in terms of connecting with apps, I think they would gladly take it, to be honest. From OpenAI's perspective, obviously monetization is a big aspect of their business. So I think this opens up a huge world for them in terms of being able to monetize it, whether it's via ads or what have you. But yeah, I personally, and I may be biased here, but I think this was a really smart move by them. I think it was. I think everything that's happening in the search industry right now, I think is only going to benefit them in terms of people adopting Atlas. I think they've done a great job of gaining mindshare and gaining a market before throwing this out, where it's a really easy switch. And to Martin's story, where he could have done it in GPT, but why not just do it on the browser, where you have all the context right in front of you. You can ask whatever question you want, have the memory cache. And yeah, I think it just makes perfect sense, to be honest.
Yeah. Martin, it looks like you might want to jump in. Or
One thing I will say, though, is as soon as you launch that browser, of course, now the decision is, do you want to switch over to another browser? And it is not shy on asking. Within about 2 minutes, it was like, can I be your default browser now? Like, I haven't even put in like 2 search queries
we're just
yet.
getting to know each other.
It also asked for Bluetooth, which I was like, why do you need Bluetooth? I do not connect to my devices.
You're like, for reasons.
Exactly, for reasons.
Well, this is a nice segue to the next topic I want to cover. So, Andrej Karpathy, who we've talked about before on the show, famously OpenAI co-founder, influencer in the generative AI movement, was on a very prominent AI podcast, the Dorkesh podcast, fairly recently. And he had this kind of much discussed set of comments that he made there, which I'll just kind of quote here. He's talking about agents. So he said, quote, "They just don't work. They don't have enough intelligence. They're not multimodal enough. They can't do computer use and all this stuff." And he goes on to say it will take about a decade to work through all those issues. And I think maybe this is actually a really nice thing to build off of, Abraham, what you just said, which is that going to be a barrier to agent adoption? I think like Andres definitely is kind of like looking at this from the perspective of a researcher who's aware of the technological limitations of what's being built. But it sure seems like people have enough confidence in these systems that they're more than willing to adopt agents, use agents, even in the presence of these kinds of problems. And so I guess maybe, Martin, to throw it to you, like, how big of a deal do you think like are the issues that Karpathy is kind of pointing out here? Should the space be worried that, it's not going to be as advanced as we thought, as quickly as we thought?
Yeah, I think when somebody who's worked in prominent positions in two frontier AI labs, in Tesla and then at OpenAI, comes out and says agents are terrible, they're oversold, and are 10 years away from being useful, some ears are gonna prick up, right, to that sort of thing. I mean, it was very interesting to hear him sort of give some of the reasons why he thinks that is the case. I mean, in my experience with this book buying agent, it already made a mistake that a human probably wouldn't do. That if I asked Aaron, like, hey, Aaron, my personal assistant, could you go out and find me that Michael Connolly book? He's probably not going to come back with the UK edition. That would be part of the processing. So yeah, you could see that. But he mentioned a couple of other things that can be sort of the cause of this. Why agents sometimes just don't do what would seem like the intuitive thing from the human perspective. And one of the things he mentioned was training data. And he said that if you took the training data set of any large language model and you just picked out a random single document from that training data set, he said, chances are that is either going to be just irrelevant, like it'll be a stock ticker figure with like some numbers in it or something, or it's going to contain just kind of nonsensical content. And he said, on average, most of the content that it's kind of scraped off the internet is just kind of nonsensical or it's full of errors. But, if you have enough of it, then you can see the signal for the noise. So it's the training data could be a big part of that. And the second sort of controversial reason he gave was were his opinions on reinforcement learning, where he also declared reinforcement learning as, well, pretty bad. And he gave the example of a math problem that the reinforcement learning works by rewarding answers that are correct and punishing answers that are not correct, but not necessarily caring too much about how they got there. So did you do the right calculations, or did you kind of stumble on it by accident, or did you add in a whole lot of extra steps that you really didn't need to do? And I think those limitations of reinforcement learning appear quite prominently in the agent's chain of thought. So when you do set an agent out to do something and you see it processing its chain of thought as it trying to work through steps, it will often get stuck in these loops where it's doing things where you think, okay, let's just move on past that, get to the next thing. And I would suspect that reinforcement learning is a large part of that it's not always finding the most optimal ways to do things. But yeah, I think when somebody like that comes out and says agents are currently being oversold, it is going to affect the industry. People are going to listen to that.
Mm-hmm. Yeah, definitely. Yeah, the downstream effect of this is going to be big because obviously there's been so much excitement about, say, what agents can do and the promise of it. And, I think there have been kind of rumblings from certainly the business space, right? I think a couple of banks have come out, and there's this report from, I feel, a few months ago that was like, oh, a lot of these pilots are not quite working out. But it seems to be like the first case of a really kind of like strong influential technical voice being like, guys, this current research plan is not going to work. Aaron, do you buy it? Like, should we really be tapping the brakes on our optimism around this stuff?
I think history always repeats itself, right? We just need to learn from history so it doesn't, the bad parts of history don't, right?
A surprisingly hard thing to do. Yeah,
That's right.
yeah.
Right. If I look back in the 90s and even 80s, we had these knowledge, based systems, right? And there's a lot of promise, around them, right? And it sort of, we entered in, into a winter of AI, right? And a lot of that was fueled by the early neural networks. It couldn't even solve the XOR problem, and so therefore we had to go to multi-layer perceptrons, to help solve that. But then we didn't have the computational ability, right? So there's always stumbling blocks and problems that have to be solved by science and engineering, right? And this is no different. I think what he's doing is very smart, right? And I think that we need to reel in lots of the overhype that we have, because I do believe it's overhyped, right? Every single company is branding AI, and they may not even know how to spell AI, right? And so we need to be careful about that. And I think Andrej's, he's taken a long haul position, which I think is what a lot of us should do, right? And he's trying to mitigate, some of this overhype. It's very risky, because we've seen it time and time again, where a system doesn't live up to its hype, but it does do what it's built to do, and so by reining in and creating those benchmarks and guideposts, it really helps us out. And AI agents, we are in the early stages. It's very exciting. It's fun to play with. But I will say, when I'm building a production system, whether it's for sports or for entertainment, I always have a human in the loop, right, to make sure that what I'm producing is consumer ready, right? And then when we go to scale, right, a 1% to 2% error rate, that's huge. That's 1 out of 100 requests. If I'm getting billions of requests, that's a lot of people are seeing incorrect problems. And that's not even to say that these systems are going out to use external tools with say, for example, MCP to activate something outside of the ecosystem, right? Which we need to be very careful. There's a lot of non-determinism, right, around these systems. And I'm studying actually, looking at when should we use machine learning versus generative AI, because there's a place for both, and when should you combine them together to get the best of both worlds. But yeah, I do think that he's taken a long haul position, and it's a very smart thing to do.
Abraham, I'll give you the last word on this topic. One of my favorite images from the moment that we're in AI, we talked about it, I think, on a previous episode, was the chart of like how the money is flowing in AI. And it's just like, it's like NVIDIA gives money to OpenAI gives money to NVIDIA. It's just like this, it's a circle, basically, is where the money's flowing. Is Andrej's comments gonna pop the bubble? Is there a bubble? I don't know what your views on this are.
I don't know if the news is going to pop the bubble. Whether there is a bubble or not, I think, I'll let everybody decide for themselves. I definitely think there's overhype. That's without question. And I think there's overhype for a specific reason that, probably predicated on a financial reason. But Aaron said something that kind of really resonated. Like the current patterns for agents are non-deterministic, whether it's, a planner or, just hitting the model as many times for inference scaling, or, they don't offer the outputs, the guardrails around outputs, in terms of I need a specific output every single time, and if it's not operating within this scope, then go back. So I think from a agent's perspective, like I think there's good enough where you're doing a search function and the stakes are low. If you don't get it, you can redo it. And then there's production grade agents where the stakes are high enough where if it's not 99+%, it's we can't move it to production. So I think there's different worlds in terms of, whether agents are going to make it or not. Personally, I think there's a need for more of a deterministic outcome for these agents. I think software is going to be kind of that. So generative computing specifically is kind of going to be that key piece in terms of making sure that agents are production grade, whether that's through policy management, whether that's through requirements or IVR patterns or what have you. 10 years, I don't know if it's 10 years or not, but I mean, I definitely do agree with the statement in terms of the overhype around agents. But I also think that there's still a place for them today. It's just a matter of being able to define where.
Yeah, your use case. Yeah, makes a lot of sense. I'm going to move us on to our next topic. The next two segments, we're going to talk a little bit about sort of interesting papers that have kind of come across our radar in the last few weeks. And I guess, Martin, I'm going to pick on you. A few weeks ago, I picked on Chris Hay. I was like, could you explain manifolds and exactly how they work in the context of machine learning? I'm not going to do anything so mean to you today, but a super interesting paper out of DeepSeek called DeepSeek-OCR. The paper is DeepSeek-OCR Context Optical Compression. And I guess, Martin, the first question to just toss to you is that the paper is trying to deal with the problem of models having trouble dealing with long contexts. And can you tell us a little bit about that problem? Like, why does that happen? What are the kind of practical implications of that?
If we look sort of the trend at large language models now, we're seeing bigger and bigger context windows to fit more and more stuff in. So the more and more stuff they can keep in mind is going to be prioritized when it comes up with a response. So how do you get as much information as you can in a certain context window, given how computationally expensive it is to expand the context window? So yeah, this was kind of an interesting idea of actually basically turning these tokens into visual tokens, and you could actually cram a lot more information into that. But depending upon the algorithm that you used, there was a certain loss when you convert it back again into text, but quite a small loss for some. So I think the best model, there was something like a 97% rate of being able to take text, basically do this conversion, convert it back again, so the decode encode cycle, and then 97% of the text was about right.
It's like not too bad.
Not too bad, right? But you could have, if you have an image with basically less information in it, that can still go through this encoder-decoder loop and still bring back text, but the text has lost a little bit more information. And what's really interesting is that they wrap this around this idea of a forgetting mechanism, which kind of mimics human memory much more. So the big thing in the paper is how similar this mimics human memory. So for example, if you run this through the best model, it basically remembers almost everything, just like I remember on this podcast the question you just asked me now, Tim. But I was on this podcast a month ago, and I remember who the guests were and what the topics were, but my memory is not fully there. Now, I don't remember the specific questions that you asked me or the specific talking points that the other guests made. So it's a bit more fuzzy. Well, they model that in this paper, and they say, well, actually, that sounds like the base model or the small model that we have, because the small model, that is considered a more blurry image and will be about the equivalent of 1 month's of human memory. So something that happened to me 1 month ago, if you use their blurry model, then that will create an image that will be about the same. So about the same amount of stuff will be forgotten there. So it sort of brings up an interesting point is there actually some utility in that having large language model context windows mimic human memory a bit more? Is there a reason that we evolved to remember things in the present very well, and then just to remember things more in abstract as time goes on? And the fact that this could model that as well.
Yeah. And the answer there being like in the biology case that like essentially it's just in the same way that it's computationally intensive for machines, it's also kind of computationally intensive for us to have like increasingly large context windows in effect. So one practical import of this paper seems to be, look, we could feed in language tokens or we can feed in picture tokens, right? I guess to make it like a very simplistic kind of distinction. The end result is that we can do a lot more compression, right? Which I guess gets us to longer and longer contexts. Is that kind of where this is all headed? Is like you can start to put even more in the window if this is actually something that becomes like more production ready?
I think about this as a document distillation, much like model distilling. You have big model, make a smaller model, right? We have a document, but we want to distill it down into principal components, and it's in this, similar from a mathematical perspective of principal component analysis, where you want to, keep the largest eigenvectors so you have the most variance that can explain, your data. This to me seems a bit similar, except we're, using these different vision encoders. So they have, a 2-stage system where they have a vision encoder called deep encoder. And it's pretty cool, because they take in a PDF file, right, but a scanned piece. And it's not just OCR, so it's not just extracting text, but it looks like it's liberating, right, the text, so we can actually see what it is. And it turns this messy human written world into something that AI can understand. And it helps to create these smaller tokens, so we can have this new way of document understanding, right? And it helps with the core problem that LLMs struggle with these long contexts due to the, quadratic scaling, that the longer the context comes, it becomes harder and harder, for these systems to process it, right? And therefore, we leverage this efficient compression technique so that we can understand this information into a textual representation. And what I think is neat in this two-stage system, when you get down to the decoder, what if you could just take that vision encoder, right, and you've, put it into a new language, then you could, train a new decoder so it like translates it into any other kind of language such that it can be used by another, large language model, any sort of multimodal model, and it just produces something very different. So I think it'll become more of like an art form, where you're putting together these different layers of encodings and decoders and finding out what best works. In fact, you could think of it like a search problem, find the best set of models and decoders and encoders to solve a certain problem in the most efficient way. But yeah, I'm excited. I liked it. What they showed here. Looking forward towards their next paper, where I think they're going to have an expanded, piece where they're going to add some more experiments to see how it works with multimodal and text and fuse together and so on.
Abraham, maybe a final question for you is like just to zoom out a little bit. DeepSeek obviously kind of got on the map in a big way through the release of its kind of open source models. It is a lab that's doing research, right, and it's publishing papers. Do you have any speculation on like why it is DeepSeek is interested in these kinds of research questions?
OCR is one of those, really old problems. So it's a great question. Personally, I think this may be just one of those innovations that they found in the lab that, demonstrated a step forward that was worth releasing. Also, I think that, the idea of having this, quote unquote infinite or longer context window is really applicable to particular RAG use cases that are, really important and kind of something that hasn't been solved across the board. So I think both those answers, kind of help them, one, make sure that their name is still in the news, but two, demonstrate that the research lab is still doing some pretty cool things. In terms of this particular paper, what I thought was really neat was, obviously shifting from a different approach in terms of how you actually encode and embed a document. What I would love to have seen personally is, is the semantic representation still kind of kept in terms of the, moving from an image to text? And what does that actually mean for downstream applications? Because that's where you're really going to see a lot of the implementation here. Or is this really just an OCR text extraction where, there's some really quick plug IBM where Dockling does this extremely well, extremely efficient in a, where you don't need an LLM to do that, to be honest. So it's a little bit of overkill in that regard. But yeah, I mean, I'm excited to see the next version of this paper and the next version of this effort from DeepSeek.
Yeah, I mean, it doesn't seem like a very flashy milestone, but it is definitely a critical piece, of the AI stack. If you take the OCR part out of this, it's a compression bridge, to help other models to, handle large-scale problems with a very small number of tokens, right? So it's pretty neat, what they're doing here.
It would be really cool. I think Aaron already kind of commented on this, but in terms of the output, like most models are text token oriented. So it would be really cool if they can release some type of plugin that you can swap out different decoder models in place of their decoder models. So this is a little bit more, from an adoption standpoint, you can kind of use what you from an LLM standpoint, what makes sense for your environment.
Do you think the next stage of this is that we're going to be seeing we already have AI art, right? Are we going to see AI art of context windows? Like, Aaron, are you going to have that picture behind you? Is that going to show some kind of visualization of your context window that we'll all be able to pick up on now?
That would be a scary proposition. You don't want to see my context window.
Yeah.
You do not want to see it. The whole notion of like effective computing, where these systems can, understand how you're feeling, what you're thinking, I think that this might play into some of it, because it's like another bridge, right, into understanding language from different areas, and that bridge could be between modalities or between people and models, in a sense, and it creates this language such that we can have other interpretations, and other agents, go ahead and run and change that image maybe behind me.
All right, I'm going to move us on to our final topic of the day. So last paper we talked about DeepSeek-OCR, a little bit kind of in the guts of the system. This other paper was just fun. It got talked about a lot online, and I figured we'd kind of bring it up here. So the name of the title is very striking. It just says, LLMs can get brain rot, exclamation point. And the intuition of the paper is kind of a fun idea. It basically says, look, there's a lot of hand-wringing and concern that if we consume lots of junk media on social media, that we will, as humans, literally get brain rot, right? Like that we will think less well, we will do reasoning poorly, have all these cognitive defects from exposure to this content. And so the researchers just simply say, like, well, what if can LLMs get brain rot too? And so what they did is they kind of curated a couple of data sets of social media content that they considered short and popular or sensationalist. And they said, well, we can do kind of like a little post-training mix to the model where we say we're going to slowly increase the amount of junk web text is what they say, or how they framed it up, to the model, and then we see how it performs against certain benchmarks. And what they claim is that these models do experience a form of cognitive decline. And so they say that there's declines in reasoning, long context understanding, safety, and then also even claim that there's the emergence of these dark traits, right? These models become like more narcissistic because they've like seen this content. So I guess, Aaron, maybe I'll throw it to you. What does this paper show? Does it show that like if we consume lots of bad material online, then our brains are literally going to rot? Or what is this? Yeah, what do we take from this paper?
I mean, the headline for me here was garbage in, garbage out. But I think the big flashing star was that the decline of these LLMs, it was persistent and systematic, right? It wasn't like, you could just quickly fix it, right? And the risk is that, as we put these systems in the wild and more training data, becomes shallower and shallower, for example, then we need to continually evaluate these models because, this brain rot, can happen. And then I sort of asked myself, why does this happen? And, I was thinking in terms of momentum and inertia, so during these, back propagation when you're training, right? I was thinking maybe there's, this extra momentum, right? And the gradients start becoming, much more marginal, right? As you learn over time. But then once you stop training, then it's like you have this inertia where you can't get or unlearn, fast enough. And it's like, humans where we have, kids and childs, their brains are very plastic. They can learn very quickly. They can change very quickly. But then as adults, you get older and older, you have such large amounts of knowledge and embedded, which is fantastic. But then on the other hand, right, because our brains are already wired, very densely as opposed to, kids, it seems as though these LLMs are becoming wired much more densely so quickly, right? Where they're sort of moving out of their childhood, in a essence, and it's harder to change that systematic perspective. And there might be other techniques that are needed, such as you could do some virtual lesioning, right? You could do some neural damaging or find what the superweights are within the model, remove them, and then train, right, to sort of remove this rot that is happening. But it's definitely a real problem here, and it does parallel human cognition. That we humans need to be careful. What we learn and what we really focus our attention on as we're out in the wild too.
So I guess, Martin, you're not really surprised by this result, right? I guess insofar as you think that this is like Aaron's interpretation is, yeah, obviously you feed in some bad content, model behavior will get worse because it's just mirroring that. So I guess how shocked should we be about these results? And like, is there anything surprising here, I suppose?
I feel like this is catnip for every parent of a teenager
Yeah,
who can say,
basically.
look what happened to that chat model when we gave it all this junk. The thing that I found most surprising, so you mentioned, Tim, that they categorized this brain rot content into really two types of engagement and semantic quality. So engagement were just kind of short pieces of information, like a tweet or something. It's just a sentence or two. It's giving some kind of factual information, but really briefly, no room for nuance. It's just like, here's this fact. And then semantic quality was the sensational stuff that, wow, look at this, that sort of thing. And there was actually a significant difference in when the model was fed M1 versus M2 junk data, the engagement versus the semantic stuff, as to the outcome in terms of personality. And the M1 data, the engagement stuff, the things like tweets, affected personality a lot more than just the sensational stuff. It seems that didn't really affect personality much at all. But the engagement stuff, the short tweet stuff, that increased when it was pushed to 100%. So all the model received was just like a bunch of tweets. It increased narcissism. It made the model less agreeable, and it made the model more extroverted. And I'm like, that sounds an awful lot like an outspoken TV pundit or something like that. So if I was training to be a talking head, like a shock jock kind of thing, this is where I need to get my training from. I need to just be looking at short form stuff, and I'll get those traits too.
Obviously, just to add to that, the M1, when trained on the M1 data, it also, you saw a sharp increase in abrupt stop in thinking. So it didn't go through the full thinking process, or it would cut it short or not do it at all. So it's just one of those weird things where it's, to your point in terms of the personality of the individual who typically wants to shock and awe versus actually have a conversation.
Well, and I think that's kind of the interesting thing here. I mean, that's like one thing I do want to get to on this paper is like how much there are these like interesting kind of confounding variables here, right? Because it may not be that it's short content, right? But it may just be that it's short content drawn from Twitter, now X, right? And so I wonder if like the presence of narcissistic, adversarial traits comes less of the fact that like the content is short form and more because of like the culture of the place where the data is being drawn. Now, I guess, Abraham, the question for you is, I guess, maybe like in the case of reasoning, because it is short, it actually limits how much reasoning it can do. And so maybe that's actually like, there's these really interesting kind of effects here, some of them related to it being short, some of it being related to, I think, like the source of it, right? Is like, certainly my feeling about X is that it's a platform where you feel that there is a lot of aggressive antisocial behavior.
No, that's fair. You only get 156 characters or 256 characters. So yeah, there's not going to be a lot of thinking kind of allowed. What I think this paper really shows is obviously garbage in, garbage out, but there's always been this notion of more instead of, quality. So this paper really showed that quality is much more important than quantity in terms of actually getting performance on your model. One thing that I thought was really interesting was they outlined that the quality of the data degraded as it was newer. So when they went through the actual corpus of training data, the more recent the data was, the lower quality it was, which was just very interesting to see that, does that mean that our quality of content is just gradually, getting to the lowest common denominator, or is this the product of just lazy literature? But it was, the paper was interesting. I think there's a lot of parallels or philosophical questions you can ask yourself based on this paper, but I'll leave that to other people.
I've always thought that it's always best to, train these large models on factually correct, dense, deep data, right? And that's your foundation model, right? And then if you want to change the personality, the tone, the pitch, prosody of speech even, that's where you use context engineering, and then you add in the traits of which you want it to behave. But it's not necessarily always the best, to try to train the traits that you want it to act like and embed it into the knowledge structure, because then you're sort of watering down, and it's kind of like brain loss, amnesia, right? Because the models are really, they're forgetting about what they know, and it's more about how should I act, right? And so therefore it becomes very watered down. And so because of that, the decline of its behavior or the way it reasons, it's not easily fixed by later instruction tuning or even cleansing the data. and it couldn't recover the baseline capability because of that, right? And so therefore, I do think that, this is a lesson learned, that when you do training and you fine tune, be really, really careful, right, about the kind of data that you do, and make sure that, you're marching towards the objectives that you want to have with the model.
Yeah, and I think if we then extrapolate that to us humans, if there is a parallel here, maybe we should be spending less time on Twitter and more time consuming high
That's right.
quality, long form content like the Mixture of Experts podcast. Huh, Tim?
Yes, exactly. Yeah, we highly recommend this. Yeah. Well, that's a great note to end on. Martin, Aaron, Abraham, always great to have you on the show, and hope to see you guys soon. And that's all the time that we have for today. Thanks for joining us, listeners. If you enjoyed what you heard, you can get us on Apple Podcasts, Spotify, and podcast platforms everywhere. And we'll see you next week on Mixture of Experts.